Our kitchens, often seen as places of warmth and nourishment, may harbor unseen threats. We carefully select our foods, wash our fruits, and strive to create healthy meals for our families. Yet, within the very tools we use to maintain cleanliness and prepare our sustenance, a subtle danger can lurk. These are not the obvious hazards of sharp knives or hot stoves. Instead, they are microscopic particles invisible to the naked eye, yet with the potential to affect our well-being in profound ways. The modern world has brought us many comforts, many ways to make life easier. Plastic, in its myriad forms, is a cornerstone of this convenience. It packages our food, it forms our containers, and it even makes up parts of the machines we use to clean. But this material, so versatile and ubiquitous, has a hidden side. It breaks down, not always into harmless components, but into tiny fragments. These fragments are now being found in the most unexpected places, from the deepest oceans to the highest mountains, and most troublingly, they are being found within the human body. Consider the simple act of washing dishes. The quiet kitchen, it seems, has secrets to reveal, and we must be willing to listen. To understand the concern, we must first understand what microplastics are. Imagine a grain of sand, or even smaller, a speck of dust. Microplastics are tiny pieces of plastic, generally defined as particles less than 5 millimeters in length. These are not a specific type of plastic, but rather any kind of plastic material that has fragmented into these minute dimensions. They can originate from larger plastic items breaking down over time, or they can be manufactured intentionally, like microbeads once common in cosmetic products. Their small size is precisely what makes them so pervasive and potentially problematic. These tiny fragments come from a multitude of sources. Large plastic debris, such as bottles, bags, and fishing nets, degrades in the environment due to sunlight, wind, and wave action, breaking into smaller and smaller pieces. Synthetic clothing, when washed, sheds microscopic fibers. Car tires wear down on roads, releasing plastic dust. Industrial processes and spills also contribute to the environmental load of these particles. Because plastic is designed to be durable, these microplastics do not easily disappear. They persist in the environment for very long periods, accumulating in soil, water, and air. They are, in essence, a long-lasting signature of our plastic age, scattered far and wide. The humble dishwasher, a symbol of modern kitchen efficiency, can unwittingly become a source of microplastic pollution. Many of us regularly place plastic food containers, baby bottles, and other plastic utensils into these machines. We trust the hot water and detergents to sanitize them, making them safe for reuse. However, the conditions inside a working dishwasher, high temperatures, strong chemical detergents, and the forceful spray of water jets create an aggressive environment. This environment, while effective for cleaning, can be harsh on plastic materials, especially those not specifically designed to withstand such repeated stresses over long periods. When plastic items are subjected to these conditions, their surfaces can begin to degrade. This degradation is not always obvious. A container might not emerge visibly damaged after one or even several washes. Yet at a microscopic level, the plastic can be shedding tiny particles. These fragments, now microplastics, are then carried away with the wastewater, or they can even redeposit onto other items in the dishwasher, including non-plastic ones like glasses and ceramic plates. The type of plastic also matters. The journey of these particles does not end in the dishwasher drain. It is merely the beginning of a more complex path. Scientific research has begun to quantify the extent of microplastic release from common kitchen items. One study focused on microplastics from infant feeding bottles made of polypropylene during preparation processes. These bottles could release millions of microplastic particles per liter of water. Another study investigated microplastic release from plastic containers in dishwashers. They found that a single plastic container could release a substantial number of microplastics during one wash. These particles then enter the household wastewater system. While treatment plants can remove many microplastics, they are not 100% effective. Once released, microplastics do not simply vanish. Their small size allows them to travel through various environmental pathways and, alarmingly, to enter the human body. Ingestion is considered a primary route of exposure. We can ingest microplastics through contaminated food and water. If plastic particles are released from containers during dishwashing and then adhere to surfaces that come into contact with our meals, or if they are present in the beverages we drink from plastic bottles, they can make their way into our digestive systems. Seafood, particularly shellfish that filter large volumes of water, can also accumulate microplastics from polluted marine environments, which are then consumed by humans. Inhalation is another significant pathway. Microplastics are light enough to become airborne, especially smaller particles and fibers. They can be present in household dust, which we breathe in continuously. Outdoor air also contains microplastics, originating from sources like tire wear and the degradation of plastic litter. Once inhaled, these particles can lodge in the respiratory system. The air in our homes, filled with synthetic textiles and plastic goods, can be a reservoir for these airborne plastic fragments. The potential health implications of microplastic exposure are a growing area of concern for the scientific and medical communities. While research is still evolving, preliminary findings and toxicological studies on plastic components suggest a range of possible adverse effects. These tiny particles are not inert. They can carry chemical additives used during plastic manufacturing, such as plasticizers, flame retardants, and stabilizers. Many of these additives are known endocrine disruptors or have other toxic properties. Furthermore, microplastics can absorb persistent organic pollutants from the environment, concentrating these harmful substances and delivering them to organisms upon ingestion. One of the most disturbing potential links being investigated is the connection between microplastic exposure and an increased risk of neurodegenerative diseases, such as dementia. If microplastics, particularly nanoplastics, can cross the blood-brain barrier, they could trigger neuroinflammation or oxidative stress within the brain. These processes are known contributors to the development and progression of diseases like Alzheimer's. The accumulation of foreign particles in the brain tissue could disrupt normal cellular functions, interfere with neuronal communication, or promote the formation of protein aggregates characteristic of dementia. Beyond neurological concerns, microplastics have been implicated in other serious health issues. There is evidence suggesting a potential link to certain types of cancer. Some chemicals associated with plastics are known carcinogens, and chronic inflammation caused by the presence of particles could also promote cancer development. Cardiovascular health may also be at risk. The systemic distribution of these particles means that virtually no organ system is entirely beyond their potential reach and influence. Emerging evidence suggests a link between microplastics and dementia. Scientists are investigating if these particles can reach the brain. Microplastics might contribute to conditions like Alzheimer's. Chronic inflammation and oxidative stress are key factors. If microplastics incite these conditions, they could accelerate disease progression. Post-mortem studies show higher microplastic concentrations in dementia patients. This finding suggests particles can accumulate in the brain. While the dishwasher is a surprising and intimate source of microplastic exposure, it is by no means the only one. We are surrounded by plastics, and their fragmentation into micro and nanoparticles is a widespread phenomenon. Our food can be a significant source. Beyond particles leaching from containers, microplastics are found in agricultural soils, potentially taken up by crops. They are abundant in marine environments, leading to contamination of seafood, particularly filter feeders like mussels and oysters. Even table salt and sugar have been found to contain microplastic particles, reflecting the pervasive contamination of the environments from which they are sourced. Drinking water, both bottled and tap, is another major pathway. Studies across the globe have detected microplastics in bottled water, often originating from the plastic bottle itself and its cap. Tap water, while generally treated, can also contain microplastics that escape filtration processes or are introduced from aging plastic pipes within the water distribution system. The air we breathe, especially indoors where synthetic fibers from clothing, carpets, and upholstery accumulate in dust, is also laden with these particles. Every breath can carry these tiny fragments into our respiratory system, highlighting the inescapable nature of this exposure in modern environments. Personal care products, though many have phased out microbeads, can still contribute. Some cosmetics and toiletries may contain plastics that wash down the drain. The sum of these exposures means that microplastics are entering our bodies through multiple routes almost continuously. Using a dishwasher for plastic items can contribute to microplastic exposure, raising the risk of serious health conditions. This issue brings plastic pollution right into our homes and onto our dinner plates. The convenience of plastic has come at a cost, measured in particles too small to see but too significant to ignore. We must cultivate a new consciousness about the materials we bring into our lives, especially those that come into contact with our food and drink. Reducing plastic usage, particularly single-use plastics, is paramount. Choosing glass, ceramic, or stainless steel food containers instead of plastic ones can make a difference. The health of our planet and our own bodies depends on our willingness to act on